Good morning, everyone. Welcome back. So in this video, we will be factoring polynomials of degree higher than 2. Okay, and the degree that so the polynomial that we will be factoring will be of degree 4. Okay, and will be an even function, even degree polynomial. So in order to show you how to factor polynomial of higher degree, so let's review how to factor just polynomial of degree 2, quadratic. So let's factor 2x squared plus 7x plus 6. Okay, so let's go over the steps. So if you know how to factor quadratic expression, you are able to factor. You can use the same logic, the same principle to factor polynomial of higher degree. Okay, remember, so the first step here, let me rewrite the quadratic expression. Okay, so what you want to do here, you want to find two numbers that add to the middle term. The middle term represents a number with the x, which is 7. And the same two numbers must equal to a times c. So the first one is to be represent the sum, which is b, the number for b, and so again, the same two numbers need to be multiplied to a times c. And a refers to the coefficient of x squared, which is 2, and c will refer to the constant, c for constant. So you have to do 2 times 6, which is going to be 12. Okay, you do 2 times 6 is 12, so a times c. Okay, now remember this is written, okay, b is 7, a is 2, and c is 6. So 8 times 6 is 12. So can you think of two numbers that multiply to 12 and add to 7? Okay, so can you think of two numbers, two factors that are multiplied to 12 and at the same time add up to 7? Can I use 1 and 12? No, right? It doesn't work because 1 times 12 is actually 12, but 1 plus 12 is 13, not 7. Okay, can you think of another factor when you multiply them together? You get 12, and when you add them, you get 7. Yeah. Should be 4 and 3. Let's try 4 and 3. So 4 times 3 is 12, and when you add them up, we end up having 7. So I'm going to use 4 and 3. So what are you going to do for two newfound numbers? So what you're going to do, you're going to replace the 7x with 4x and 3x. So 2x squared is going to remain 2x squared. And then I'm going to replace 4x with 7x with 4x plus 3x. And I'm going to bring down the plus 6. Why? Again, remember 4x plus 3x add up to 7. So now you have a term and a quadratic expression made of 4 terms, 1, 2, 3, 4. Okay, so you can use the box method or by grouping. Okay, so let me show you the box method. So a box is made of 4 squares, so you have to have 4 terms. And here you have 1, 2, 3, 4. So you write 2x squared here. And the term, the leading term, the term with the highest exponents, always goes on the top left. And then you have here 4x, and then 3x, and then you have 6 right here. And the constant always goes to the bottom right box. Then the goal is to factor out the greatest common factor. Okay, so look at 2x squared and 4x. Which one is the greatest common factor? Which factor is repeated in both, in 2x squared and 4x? Okay, it has to be x, because I have 1x in x squared and 1x in x. Now the number, because I see 2 and 4, I cannot use 4, the factor 4, but I can use 2. Why? Because 2 is a factor of 4, and 2 as well is a factor of 4, so I can pull out 2. Now, what is the greatest common factor between 3x and 6? So the common factor repeated is, I hope you can see that. Okay, so the 3x, the factor of 3x is just 3x, and the factor of 6 is 3 times 2. So the repeated factor, which we call in algebra the common factor here, is going to be 3. So I'm going to pull out 3 outside. The repeated one, you bring it outside. Okay. Now, let's move on vertically. So what is the repeated factor? It cannot be 2, right? Because there's no factor of 2 in 3. Okay. So there's 1x. And the common factor here cannot be 6, or it cannot be x because there's no x by the 6. Okay, and it cannot be 6 because 4 is not a factor of 6. So the factor repeated in both between 4 and 6, I hope you can see. Let me show you. So the factor of 4x can be 2 times 2x, and the factor of 6 can be 2 times 3. So the repeated factor is going to be 2. So you're going to pull that out. Right. So let's check our work by multiplying. 2x times x is 2x squared, 3 times x is 3x. 3 times 2 is, 2x times 2 is 4x, and 3 times 2 is 6. So now the factor form is going to be 2x plus 3 times x plus 2. So if you don't see the plus sign, the sign next to the 2, assume it's positive. So write the plus. And this is the factor form. Okay. By grouping, I'm going to group the term on the term on the left together. Then I'm going to group the term on the right together. The two terms on the right together. So the greatest common factor between 2x and 4x is 2x. Okay. And for 3x and 6 is going to be 2 as it's going to be 2. No, 3, sorry. So now you see that the factor x plus 2 matches. We have the factor x plus 2 on the left and on the right. So you're going to keep on factoring the common factor, the repeated factor, which is x plus 2. And the leftover is going to be x plus 2, no, 2x plus 3. And that's the factor form. Okay. So I hope this is a review on how to factor quadratic expression. Okay. Now the same principle you use to factor 2x squared plus 7x plus 6, you're going to use that same logic to factor quadratic expression, polynomial expression of degree 4. And the expression is x to the 4th power plus 3x squared minus 4. As you can tell here, this is a polynomial of degree 4, okay? And we also call in algebra, we call this an even, it's an even degree because the highest exponent is an even number, okay? And in algebra, we also call that the even function. Why? Because you can notice that every exponent, okay, is an even number. Even the 4 as a variable x, but the exponent is 0. Okay, and we consider 0 as an even number. So when we see that every exponent, okay, on the variable x is an even number, like here you have 4, 2, and 0, you're going to use the same logic as we used to factor this quadratic expression here, 2x squared plus 7x plus 6. The same logic that you used to factor, quadratic expression. The exact same, but the only difference is instead of using x squared, you have to write x to the 4th power. And instead of using x, you're going to write or use x, okay? So again, the goal here, you want to find again two numbers that add to what? You want to find two numbers that add to the middle term b, which here, b here is 3. And the same two numbers needs to multiply to a times c. So the number in front of x is not, the number in front of x is not 0. A is not 0 here, it's 1. Okay, there's a 1 right here. Okay, so 1 times -4 is -4. So can you think of two numbers that multiply to -4 and add to 3? Okay. I'm thinking about 1 and 4. Okay, but one of them must be a negative number because the product is negative. But the sum is positive, so I mean the bigger number needs to be positive. So it should be the one's going to be negative. Okay, let's check. -1 times 4 is -4. -1 plus 4 is +3. So what do we do next? You're going to replace. You're going to replace the middle term with what? So be alert here. Remember you use x to the 4th power, and instead of using x, you're going to use x squared, -1x squared plus 4x squared, and then you're going to bring the -4. Okay. I'm not going to do both methods. I'm going to use the box method. Okay. So the greatest common factor between x4 and -1x4 is x squared. The greatest common factor between 4x4 and -4 is 4. So the greatest common factor between x to the 4th power and 4x is x. Okay, and right here is going to be -1. If you don't see any common factor, it should be either 1 or -1. Okay, so the trick here, okay, I went fast, but the way I was able to identify the greatest common factor is I know that x to the 4th power is x times x times x times x times x, and I have -1 x squared, which is -1 times x. Okay, I agree. Now, the greatest common factor cannot just be 1x, because 1x will be the lowest one, right? The greatest one will be not 1x. You see that you have x times, it should be x times x, okay? Which is here x squared. So I can pull out x squared outside, okay? And the same principle I've done with 4x squared. So 4x squared can be written as 4 times x, and -4 is -1 times 4. So the greatest common factor here, the factor being repeated, is the number 4. So that's why I pull it out right here. And the same principle I use for x to the 4th power and 4x squared. Oh, it should be x squared here. I just realized. Okay. Okay. So the greatest common factor is going to be x squared. It cannot be 4 because you don't have a 4 by the x to the 4th power. Okay. So the factor form is going to be x squared minus 1, okay, times x squared plus 4. Okay, we can continue factoring further the x squared minus 1. Why? Because in algebra, when you see the difference of 2 squares, okay, you can factor it as, let me use that formula. I believe I didn't show it to you yet, but let's use, so the way you can factor the difference of 2 squares as a minus b times a plus b. So if you notice, if you can write two numbers as a square and the operation used between the two numbers is subtraction, you can just write 2 factor. And as you write the 2 factor, you want to drop the square, okay? And then you want to make sure you use opposite sign. The reason is because there is no middle terms with the x. There is no term with the x. So that's one term. Inside of one, you have to have a minus and the other a positive. So the middle term can be cancelled. So you will see that further that you can factor this as, okay, this is x squared minus 1. And remember, x squared, 1 can be written as a square, which is 1 squared. So its factor form is going to be x minus 1. Remember, you want to drop the squared. And then if you have minus, the next is going to be plus 1. So if you multiply these together, you end up with x squared minus 1. And let me show you what I mean by this. So let's multiply. You end up with x minus 1 and x plus 1. So x squared, 1x. Okay, so you end up here with x squared plus 1x. This is also -1x. Okay, minus -1, minus 1x, minus 1. Again, you have 1x and you take away 1x, they cancel out to 0. Okay, and you're left with x squared minus 1. So that's why it's important that you make sure that the sign are opposite inside the factor, are opposite of each other. So the middle term can be cancelled. Okay, and you are back to the original quadratic form. So now I can factor x squared minus 1 as x minus 1 times x plus 1. And this one I'm just going to leave it alone. Because we can still factor this, but you call that the sum of 2 squared. And I don't want to, yeah, so I'm keeping the factoring for the sum of 2 squared for accelerated algebra 2. So again, please make sure that if you don't know how to get from here to here, please, if you know up to here, that's fine. Okay. This week, I'm going to show you how to factor the difference of 2 squared. Okay. So if you know up to here, that's great. Okay, that's fine. but the goal is for you to be able to go from here to here by the end of this week. So thank you for watching my video, and I hope it was beneficial. And we now know how to factor polynomial expression when every exponent is an even number. Okay, so for you to check, for checking for understanding, checking your understanding, CFU, check it for understanding. Can you factor x to the fourth power minus 10x squared plus 9? Okay, please pause the video and do so, okay? Please factor it. Okay, so this is the work. Okay, the final factor form is x squared minus 9 times x squared minus 1 times the factor of x squared minus 9. And x squared, the factor x squared minus 9 times x squared minus 1 is the same thing too. Okay, multiplication is commutative. Okay, 2 times 3 is 6, as to do the same thing as well as 3 times 2 is as well 6. And 2 times 3 is 6 also. So it doesn't matter the order, which comes first, which factor comes first. Okay, so I show you both ways. So please pause the video, okay, and make sure you understand the steps. Okay, again, it was my pleasure teaching you today. Okay, I hope you learned a lot, and I wish you the best. Okay, so see you into the next one. Bye bye.